Welcome to this video lesson, which is the full solution to the practice questions from the two-dimensional lines, parametric, and vector equations. In the first question here, we're asked to state the direction vector for the lines that are parallel to these three lines. And the first one is given to us in parametric equation. In parametric form of equation for the line, the direction vector is the coefficient of t. So in the x direction, the coefficient of t is -2. In the y direction, it is 3. So the answer for A is going to be vector -2 and 3. For the second part, our equation is given in a form of mx plus b, meaning that this is the slope of the line and this is the y-intercept. The y-intercept doesn't give us any information about the direction, but the slope does. So in this case, our slope is equal to -2 or -2/1. And if we were to draw this out, we would have a rise of -2 and a run of 1. So you would have a run of 1 and rise of -2. And our direction vector tells us the movement in the x direction and the y direction. So our direction vector, let's call it B in this case, is going to equal to, in the x direction we go by 1, and in the y direction we go by -2. For part C, the form of the line is given to us in vector form, and this is one of the easiest way to figure out the direction vector. The direction vector is just whatever is being multiplied by t, so in this case our answer is going to be vector 4, 3. The next question is asking us to determine the parametric and vector equations for a line that is parallel and perpendicular to one that passes through points 1, 1 and -3, 8. To come up with an equation of the line, we need a point. In this case, we have 2, so we're good there, and we need the direction vector. For the direction vector, we can either use vector AB or BA. It doesn't actually matter. So let's find vector AB, which is going to be our direction vector. To find vector AB, we're going to take the coordinates of point B, and we are going to subtract them by coordinates of point A, which is 1, 1. By doing this, we will get -4 and 7. And this means that the direction vector, which is parallel to our line, is going to be -4, 7. Put parallel here. To find the perpendicular direction vector, we're going to just draw it out. In this case, we got -4 is in the x direction, 7 is in the y direction. So our slope here is rise over run, which is 7 over -4. And if we want a line that is perpendicular to this, our slope is going to be the negative reciprocal of this. So our slope of the perpendicular is going to be +4/7. So if we were to draw this line, the rise is going to be 4, and the run is going to be 7. So our line is going to look like this, and rise is 4, run is 7. So we move 7 in the x direction and 4 in the y direction. We can also use the idea of negative reciprocal here as well. So in this case, we have the -4 and the 7. So we take the negative of this, which is just positive, and we switch the two to get 7 and 4. That's kind of the shortcut. Here is how we do it conceptually. Once we have the direction vectors, everything else is just straightforward. So for a line which is parallel, the vector equation r is going to equal to one of the points. We can choose any of the points A or B. It doesn't really matter. So I will choose A. It'll be 1, 1 plus some parameter. Let's use t here. And our direction vector for parallel is negative 4, 7. And we can turn this into a parametric equation by writing x is equal to the point here plus t times negative 4, which is negative 4t. So I'll write it like this. And y is equal to this point here, 1 plus t times 7, which is 7t. I do want to simplify this. X is equal to 1 minus 4t, and y is equal to 1 plus 7t, and that is our parametric equation. For the perpendicular, we're going to use the same idea. Note that this question has just given us this idea that we want an equation which is perpendicular to a line that passes through these 2 points, but we don't actually know through which point it's moving from. So the question is a little incomplete here, and that's me to blame for. But we're going to assume that it goes through point 1, 1 here. But again, the question should really mention which point it goes through. We're going to choose a parameter. I'm going to use lambda for this one. And our direction vector for this one is 7, 4, as we found right here. And to write this in parametric form, we have x is equal to 1 plus lambda times 7, which is 7 lambda, and y is going to equal to 1 plus lambda times 4, which is 4 lambda. And that's our parametric equation. For our last question of this video, you are riding on a car with an average velocity. So the average velocity is given to us in kilometers per hour. Your starting position is 50, 30 based on a grid map. So we can kind of assume that the first value is in the x direction or the east direction, and the second one is in the y direction or the north direction. And first we want to determine the vector equation. For a vector equation, we will need starting point. So this is our starting point. Our starting point is 50, 30. So that means the position vector to our starting point will have an x value of 50 and a y value of 30. And our velocity vector is 60, negative 40. That gives us the direction that it's traveling every hour. So we're going to multiply this by time. So in 1 hour, it will travel 60 and negative 40. And if we increase our time to 2 hours, that means it has traveled 120 in the x direction and negative 80 in that direction, and so on. Once we have our equation, this is the vector equation for it, we want to determine the time required and your y position when your x position is 182 kilometers. Okay, so we're given our final x position. To do this question, we can leave it as vector form, but I do like to write these in a parametric form. This is x is equal to, I'm going to take the top and the bottom for y. So for x, we have 50 plus 60 times t. And for y, we have 30 minus 40t, because we got negative 40 times t. We are given our final x position. Our final x position is 182. And that's going to equal to 50 plus 60t. Well, we can find our t value, or the time it takes for us to get there, by rearranging for this. To rearrange for this, we are going to subtract both sides by 50. And we are going to get 60t is equal to 132. And then we're going to divide both sides by 60, and we're going to get t is equal to 11 over 5, or 2.2 hours. And that is one of our answers. And if we know that it takes 2.2 hours to travel, that means we can plug that t value into here to figure out what our y position is. So we're going to do that. So for the second part, we are going to do y is equal to 30 minus 40 times 11 over 5, or 2.2. This simplifies to 30 minus 88, and this will become negative 58 kilometers, and that will be our y position. So putting this all into perspective, if we had a grid, let's say our grid starting position was here, and sorry, this is not our starting position, but this is a 0, 0 point, or the origin, and originally we were somewhere here, that is point 50 and 30, and we traveled in direction 60, negative 40, so that means 60 in this direction and negative 40 in this direction. So that's our that's our velocity vector, that's 60, negative 40. And as we're traveling in this direction, we're going to go in the east direction, and we're going to go in the south direction. So in 2.2 hours, we've reached a position, our final position here, which was 182 kilometers in the x direction relative to the origin here, and negative 58 in the y direction. So our final answers to these then, t is 2.2 hours, or 11 over 5, and y position is negative 58 kilometers.